Making Tools was presented as part of the Flash in the City conference. This presentation was originally recorded on June 11th, 2011, in New York City.
Yes, so hello. Today we're going to talk about making tools, and this is the third time I've done this presentation. I did it once at a conference a couple months ago here in New York, which I probably shouldn't mention. It's a competition. And I did a local user group the other day, and it's come to my attention that this is a pretty good talk. People like it. It's got some interesting stuff. The name really sucks because every time somebody says, "What are you speaking about?" I said, "Making tools," and I get the smile. Yeah, as in, and I kind of explain it, and they're like, and then I explain it some more, and they're like, "Oh, yeah, that's cool. Yeah, I want to see that. That's good." So I don't know why you're here or what you expect, but hopefully it'll be something interesting. What's next? So what I want to cover here today, I saw this thing about when doing presentations, you should lay out 3 things that you're going to answer. So what are tools? Which basically, hopefully you know what I'm talking about. Otherwise, I don't know why you're here. Why you would want to make tools and how you make tools. Some tips on how to make them. And we'll start with what tools are. And I always like to start with a definition. And so this is the definition of a tool. A lot of different things going on there. Oh, I get the first laugh, which means somebody made it to the bottom. Okay, so we're mainly looking at these ones here. So we have an implement, especially one held in the hand. So we're talking about hand tools here, right? Things that, we're not talking about a lathe or a bench press or something when we're talking about physical tools. We're talking about, things that are usable and, portable and you can use them in different cases. And if you transfer that into the software world, you're talking about not, huge IDEs and stuff like that, but these smaller tools that you make that serve many different purposes. And I like this other definition too. Anything used as a means of accomplishing a task or a purpose. So it's something that you use to help you do something. And if we look at the history of tools, when I was a kid, they taught us that the difference between animals and humans is that animals use tools, right? We use tools to do things, and animals don't use tools, right? But that turns out that that's actually kind of false. A lot of different primates are known to use tools to, get food or accomplish different tasks. Not even just primates, but crows have been seen to use tools. Elephants, dolphins will use various things that they find. Even octopus will use tools to, get food, or I don't really know what else octopuses do other than eat, but apparently they use tools for that. Otters, sea otters, they'll grab a rock out of the bottom of the river or whatever, and they'll use that to crack open shells. Even certain rodents will use a stick or some kind of, a tool that they find to do whatever they do, whatever rodents do. So the definition has been kind of changed since when I was a kid, and now we realize that humans are actually the only ones who use tools to build other tools, right?
That's not true. Crows can't build tools.
Well, see, somebody else is going to do a presentation in a few years from now, and they're going to go through a whole other cycle. So we're always learning. What's that? Oh, excellent. You may have added to my next presentation. But beyond what he just said, well, anyways, this idea of using tools to make other tools, I'm sure even crows don't do it to the level of humans do. And I think, sometimes as programmers specifically, we get in this loop of tool making, and you're using a keyboard to enter text into which is a tool, to enter text into a computer, which is a tool, on which is running an editor, which is a tool, which you then use that code to run through a compiler, which is a tool, and what you're building is another tool, and that tool might be used to make another tool, and you can get in this whole, does anything ever come out of this? Do we ever actually make anything, or is just this whole circle of making tools is kind of I don't know. These things keep me up at night. I found this other cool definition of tool, more specifically as applies to computer tools. So it's something that creates, manipulates, or modifies other programs. So it's a program that does stuff to other programs, such as a compiler or an editor or a cross-referencing program, right? So that's pretty cool. So it's a program that you make to help you make other programs or change other programs or do something with other programs. It says the opposite here, but I don't think an app is an opposite. It's just kind of a different thing. And an operating system is obviously where all the tools and apps run on. And then I'm running Ubuntu these days, so I've been kind of getting into the Linux and Unix kind of thing. And there's this thing called the Unix philosophy. There's a few different versions of it, but this is a simple one. So in Unix, particularly earlier when it was all like these text-based tools, you'd have these like little tools, these little command line programs that would do just one thing, right? And that's, the first thing. You do one thing and do it well. You don't have this huge thing that tries to accomplish everything. You have one tool that does it well. This lists directories. That's all it does. It just lists directories. It doesn't sort them and do this and do that and print them out and format them and all this other stuff. It just makes a list, right? And then you write programs to work together, and that goes into the last one that you want to handle text streams because that's universal. So, you can list your directory, you can pipe that into another command that will sort it, and pipe it into another command that will search through it for certain patterns, and pipe that over to something else that's going to write it to a file or send it somewhere or something like that. Moving beyond text-based tools, you're not necessarily handling text streams, but you can kind of cross-apply that to, if you're dealing with images, use, PNGs or bitmaps or something like that. If you're using video, use some like common thing. Don't make tools that rely on some custom binary format. Just use the common thing so that you can use them on many different applications. And so why would you make tools? Like you go out and you pay thousands of dollars for CS5, or you have Eclipse, which is like a 17 gigabyte download, or Xcode or something like that. We're paying these money for tools and we're installing these huge things. Why do we need to make our own tools? Shouldn't these other tools do everything for us? Well, the fact is they don't. So here are some of the reasons. One is the DRY principle, don't repeat yourself. And this comes from coding, whereas if you write a function once to do something, you're not going to rewrite that same block of code over and over every time you need it. You're going to write a function that you can just run at any time. And then maybe abstract that so you can use it across many different programs. So same with tools. If you find yourself doing the same routines, same actions over and over, building an application or doing graphics kinds of stuff or anything, sound, whatever you're doing on the computer, if you're doing it over and over, make a tool to do it for you. Speed, obviously the computer can do things faster than you. You can loop through things. You can process data much faster than going through a text file line by line and trying to change things manually. Quality and accuracy, again, if you're going through a text file and trying to find every instance of something and replace it with something else, the computer is going to do it a lot more accurate. You're probably going to miss something. You're probably going to mistype something, whatever. Computer, we complain about them, but usually it's our fault, something we messed up. I think that's one of the key things about a programmer when he realizes that the computer really doesn't make that much mistakes. It's usually him or her. Visualization, the computer can see things you don't. So this is why we have debuggers and profilers and stuff like that. When you're running a program, you basically see the interface that you created when you wrote the program. But you can write tools that can look into the memory, look in behind the scenes, and see other stuff that you can't see. Another concept of visualization is that a lot of times you're writing code, say for visual things or graphic things, and you're writing this code, that the code you're writing you can't really visualize what that's going to create on the screen until you run your program. So sometimes it's nice, and we'll see some examples of this. You write a quick little tool that will help you visualize that code quickly, and then you can kind of mess with it easier, and then when you have what you want, you can take that code that the tool wrote and put it in your real program. Iteration, again, you can try thousands of different iterations on a computer within a few seconds. It's not going to complain, it's not going to get bored. It goes back into speed where you can do that a lot faster than you could by yourself. And writing tools is fun for me. A lot of times you get stuck on a big long project, and you have your deadlines, and you have your sprints, and you have your tasks, and your bug reports, and you have your daily Scrum meetings, and you have your project manager, and you have your design documents, and all this stuff, and you're like walking down this little tight alley, and it's kind of fun to sometimes go off, for a couple hours or a day or something, and build some tool that's going to help you. In addition to saving you time in the long run, it's kind of fun to just work on something else that, you're the project manager, you're the designer. It doesn't really matter what it looks like or if it's kind of not fully functional. You just kind of go off and do this for a little while and get a little break. And I find it's a good way to experiment with different architectures and stuff. A lot of patterns I've learned just from doing these like little one-off projects. And you can experiment and you're not going to mess anything up. So we'll show a few of these. The first one is a tool I created a little while ago called SwiftSheet. And let's see. I want to go over here to Windows, I think. Yeah. So if you've ever done any games, a lot of games use sprite sheets, which is just a bitmap with a whole bunch of frames laid out, usually in a rectangular grid, or sometimes they're packed in there or better. And then you just display one part of that bitmap at a time to loop through and make an animation. Now, coming from a Flash background, I find that Flash is like a really incredible way to make animations. You have the timeline, you have drawing tools, you have tweens, you have 3D, you have the bitmap effects, and then you have ActionScript, which is a really cool language that you can animate things in real time. And anybody who knows me knows that I like to do that stuff. The thing is, if you make a Swift that's an animation, like say you want to make a game, right? Swift is great for a Flash game, but say you want to make that an iPhone game, like a native iPhone game or a native Android game or something like that, you can't use that Swift somewhere else. So I was doing this a couple times, and I was trying to transfer the frames from this Swift over to a sprite sheet, and it was pretty tough because Flash does have this export to bitmap sequence thing, but if you've ever tried to use it, it's completely useless. And I have a few laughs in the audience, which means they have tried to use it. Because basically it only does the main timeline. If you have nested animations, it ignores them. If you have code, it ignores it. A whole bunch of other stuff it ignores. So, the animations I was making were more coded and nested and stuff like that, so it didn't do anything. So what I was doing is just advancing my animation one frame, taking a screen capture, copying that into a large bitmap, positioning it just right, and doing that again with the next frame. And I did that once, and that was enough. I didn't want to do it anymore. So I wrote this tool that does all that automatically for me. It's called SwiftSheet, and I'll give you a quick demo here. So this is it. It's written in Adobe Air. It's an Air application. And what you do is you load a Swift in here. So this is the Swift. You can see that this is the actual loaded Swift running here. And this is a bitmap where it's drawn each frame of the Swift on here. And over here I'm using this bitmap showing one rectangle at a time down here to animate. So this is the result of what your bitmap is going to be. Now the problem here is that I know this animation has 60 frames, but over here we're only showing 15 total frames. So the first thing we need to do is correct that to 60. Now if we recapture, well now you see our bitmap isn't big enough because it only holds 25. So we can do two things. We can make a larger bitmap down here, and now that's fine because now it holds all 60 frames. But if we go back to the 512 by 512, you notice there's a whole lot of white space here that we don't really need. That's kind of wasted, and we don't want to make these huge bitmaps to add to our application when we don't really need to. So we can do something like change the frame here, If you notice the red rectangle around the animation there is changing. So now we're just covering the actual space of the animation here. And we're kind of freaking out down the bottom. But if we recapture that, so now it's packed in there nicely. Totally fits in a 512 by 512 bitmap. One other thing you notice here, you'll notice a little hiccup here every once in a while. And what that is this SWIFT was created with ActionScript. And so I have this, I do an event listener, and I have these two, I'll show you quickly. Oops, sorry. So in the library, I just have this spinner, which is just a circle, very simple circle. And I'll just close my SWIFT there accidentally. So here, I add two of these things to the stage, and then I do an on-enter frame. And on each frame, I transform these with the scale and the rotation, and to make that animation. So what's happening here is you see this first frame is before the on-enter frame started running. So I just have these two circles here that are untransformed. So we don't want that. So we can just say the first frame to start at 2. And we capture that. And now you see the first frame has that transform. And this is nice and smooth down the bottom here. And now I can save this sheet. And it'll save it out as a bitmap, right? And we can just do that. Sheet dot, I think it's a PNG is what it saves as. And you can save metadata. So various game systems have different XML or text formats that they use to describe like which frame, which rectangle is which frame of the animation. So there's a few different common ones: Zwaptex, Corona, Sparrow. I just made a generic XML or raw text. So you can export that XML or text as well. And I'm just going to skip that. And you can also export a PNG sequence if you want. And then we can just see somewhere here, we created this sprite sheet here. And that's the sprite sheet that was exported. You can use that in an iPhone game, a Windows Phone 7 game, pretty much anything, Android. Another Flash, if you don't, sometimes it saves memory to use sprite sheets in Flash as well. So these can be used across any platform. You can use Flash as a great tool to create the animations, and then use this tool to export it and use it anywhere. So that's that. So my site is bit-101.com, and if you just search for Swift Sheet there, you'll find it. And it's pretty good. This next one is, you guys know Stacy Mulcahy. She's a very good friend of mine. I like hanging out with her. She created this. Well, actually, I created this tool. Actually, I didn't create this tool. I had an idea for a tool. And it was one of these things where, this would be I'm going to do this someday. I just don't have time to do it right now. And it kind of sat in that state for a few months. And then one day I was IMing with Stacy, and she said, I had this great idea for a tool. And she described the exact thing I was thinking about doing. And I said, go for it. And so here's what it is. So if you ever work in Flash, who's written code like this before, right? So you embed something. You embed source and a path to an asset, usually a bitmap or whatever, and you write a public var or whatever, public or whatever name, which is a class, right? And then you can instantiate that class and have that bitmap of that PNG. So if you do that, you can kind of put these embed statements all over your code and have them all over the place, and it gets pretty messy. So usually what you end up doing is you create a class. I usually call it library, and you have just these static variables, one for each asset. So if you want to change your assets or change, add new things, you know they're always going to be in the library. And you can always do library.catPick, and that will, that's your way to get at that particular asset and create one. And that's all cool until your designer hands you a zip file containing like 1,700 PNGs or whatever that have all different names and different types, or like a nested directory of fonts and PNGs and sound files and all this other stuff. And you got to write each one of these lines of code by hand. That's kind of a pain in the neck. So this is all stuff that Flash is great at. It's reading directories, recursing through directories, writing out text files based on file names, and saving that as a text file. And so I present to you Embedded Bitch, which so Stacy Mulcahy, her website and Twitter handle is Bitch Who Codes, and look at there, she's right there. Good timing. So I didn't make up the name. That was Stacy made it up. But I will show it to you. So you just run this. So let me actually, over here. So you have an assets folder, which you'd probably have in your project. And that has fonts and icons and Swifts, and it has some XML that you might want to embed in your project. So it has a symbol Swift, and it has some icons, which are a bunch of PNGs, and has a font folder, which contains georgia.ttf, right? So we run this. Again, this is an Air application. And you need to browse for your asset directory, so that's in desktop assets. And then you can choose all the different asset types that you want to embed. Maybe you don't want to embed all those, but you probably will. And then you want a name for your class, and so we'll say com.stacy.library. And then where are we going to save this file? We'll just save it right on the desktop. And then there's some other options down there, scale 9, symbol syntax for Swift, where you can embed individual symbols, Unicode range if you want a specific range of fonts. And then you can either get it for the clipboard, or you can say, write that file, bitch. Well, of course, choose that option because it's humorous. And here we have a library.as. We open that up, and sure enough, we have the package name, the library, the class name, and we have, assets.font. This is she needs to fix the path separators, because this is on Windows, so it's got the backwards, forwards thing going on there. It'll probably still work anyways, I don't know. But anyways, this is you can bug her because she hasn't released this except to me. So if you want to copy this, she's the one eating the yogurt here. She's going to kill me later. All right. The next one is a tool I made a few years ago, back in CS4. Somebody, I was misinformed when I named this, and somebody caught on to it right away and gave me a hard time about it. I don't even know what that means, but so basically, back in CS4, there was actually this started with Lee Brimelow, was doing did a blog post where he created this like a snippets tool. Now Flash CS5 and 5.5 has a snippets tool in it, but Flash CS4 didn't have anything. So he created a snippets tool, and I thought that was pretty cool. But I had this idea, like some tools like TextMate and some other tools have this thing where you can just type like a little word and then it'll expand into whatever you want. So I made this thing where you can do the same thing. So I'll just use this. Say I wanted to create a bitmap. I can just type this ampersand bitmap and hit this key combination and hit this key combination. Damn it. Oh, it's killing me. Oh, because I'm in an AS file, that's why. This only works on the actions panel. It doesn't work in the code editor in Flash, which for some reason are two different things. So say I want a bitmap. Bang. So I just type bitmap and I get bitmap data equals new bitmap, blah, blah, blah. If I want a sprite, new sprite, right? If I want to add an event listener, say mouse down, right? Stage out event listener, mouse down, creates the function for you, right? And this is really useful for me, just experimenting. I do a lot of experimenting in Flash, and doing the same things over and over again, make it easy. So let me just show you how I wrote this. This was in JSFL. So it's a command. It's a JSFL command, and I just mapped. You can go into map keyboard shortcuts, and I assign that to Control E. And let's see if we can. Hopefully, no. Now I have to find it here. They make it so easy. There it is. Yeah, it's going to run it, ain't it? Oh, here we go. It's right here. So this is just a JSFL command, and all it is, it's a map, which is an object, and I just have keys here, which is each one of the shortcut words I want to use, and the key maps to the actual code that I want to write. And when I run it, it just basically, runs through the actions panel, gets the script, gets the text from the actions panel, and then looks through the keys in the map. If it finds that, it splits it and joins it, replaces that with that. Very simple. And this way you can add your own commands. If you don't like the ampersand thing, you can change that to percent or whatever you want. And again, if you look up AS Expander on my site, you'll find this there. It's a few years old, but it could still be useful. How am I doing for time? When do I got to be out of here? Nobody knows. I'm just going to keep going until they take me away. So Explorers, there's a thing, I've done some Explorers, other people have done some Explorers, and this goes back to what I was saying about visualization, where you're writing a command, you don't know what it's going to look like. So let's see. Get some of these here. Documents. I think I have these in here. So for instance, Perlin noise, right? It's got, 8 different parameters, and you don't really know what that's going to look like. So this is the Perlin Noise Explorer. So if I just start with the default ones, this is Perlin Noise. And if you see down the bottom here, it actually writes out the exact code that you would write to make this particular pattern of Perlin noise. So we can go like fractal, grayscale, change the base X a little bit, change the base Y a little bit, add a few more octaves, render that, and now we have this kind of cloud-looking thing. Again, there's the code. You can mess around with this pretty easily. Copy this, paste it into your application, and you're going to create that exact pattern of Perlin noise. Pretty simple. Noise, another Explorer, same basic concept, a lot more boring. You have noise, you have grayscale noise, you can have light noise or dark noise. You can change the random seed. Again, it's pretty boring, but copy the code right down there, you put it in your application. Tween Explorer, this has been a few different ones of these. This is not one I created. This was created by Greensock, the guy from Greensock who does Tween Lite and Tween Max and all those. So again, you have your tween, your target, and say tween, and you can see what it looks like, and you get the code, the AS3 code down there, or you can get the AS2 code. We can move this guy back here. You can scale them on the X and Y axis. A little like that. You can rotate them. So you can kind of build your tween visibly. You can kind of fade them out a little bit as he goes. And then you can change your easing function. And then you see what he looks like there. And again, you have all the code written out for you. It's much better than like writing this, changing a value, recompiling, changing another value, recompiling, changing another value, recompiling. You just do it all at once. Bang, you got it. So these are the little tools that you can build. Anyone remember XPath? This was before we had E4X in Flash. This was how you like recursed or like search for nodes in XML. So if we take some XML here, and go over into our tool, paste it in here, and then we can just write XPath queries, I guess you would call them. So we're searching for anything called node, and we get 4 nodes listed. These are the results, 4 different nodes. If I want to select a single node, it will just get the first one. Oops. Sorry about that. Go. So that's just the first node. So this was pretty useful to me back in the day when we were using XPath. There was an XPath library. You could probably do the same thing for the E4X stuff. It's very simple to write a tool like that. But I don't have one to show you. Another one is, hopefully I have internet here. Regexer. If anyone's ever worked with regular expressions, they can be pretty painful. So Grant Skinner created this tool called Regexer. A really awesome tool for using regular expressions. Even if you're not using them in Flash, it's a great tool. If you're ever using regular expressions on anything, you just you paste the text that you want to search in here, and then you write your query in here, and it's got some the common shortcuts over there, and your different options up here. And say you want to search for G Skinner. See, outlines gskinner.com right here, right? And you can use all your backslashes and dots and stars and brackets and all that stuff. And then there's a replace option here. So if you want to change it to a better URL, you can do like that, and gskinner becomes bit101.com. So you can improve your code that way. A few people got that, okay. All right. Let's see. Where's my presentation? Somewhere. There we go. Okay, space-time is another one. I was asked by last year about this time. Scientific American had seen some of the Flash artwork that I've done, and they asked me to do a piece for an article they were doing on space-time. And that was pretty cool. They had some images that I had done that they wanted something like this. And what they wanted, though, is they wanted 4 images, but they wanted me to submit 12, and they would pick 4, and then they might need to change those a little bit to fit in the layout. So I was like, how am I going to do this like algorithmic generative art that I can then go back and like change somehow after they've picked it like a few weeks before? So I came up with this. I made a tool to create this stuff, and we will run it as a, oh, no. We run it as a, here we go. Again, this is an air application. And so the idea is there's a whole bunch of particles, like 1,000 particles. They come up from the bottom. They have random colors. And these things can attract them or repel them. And they make interesting patterns. So if I, let's see, I go into preview mode here and I run this. So these particles come up. See, this one pulled stuff over here a little. They kind of messed with the gravity there, and they kind of curve around there. And then you can stop running and clear that. You can kind of move these around. If these are negative, they will push stuff. And we can run that. And see, now they're pushing them away. And you can kind of get some interesting patterns here. Ooh. We run this again. We turn off preview mode, and you see it's actually drawing much slower. So I made the preview mode, it draws in much lower resolution, so it's much faster to visualize things quicker. But then when I have a pattern I like, I can just turn off preview. And now if you go into zoom, you see this is actually zoomed way down, scaled way in. This is 100% here. So what you're seeing in the other mode is like actually scaled way out. But this, obviously this had to be printed in a magazine, so it had to be very high resolution. So this is what the print version would actually look like. And then if I stop running this and then I save this, see, I don't have to choose a file name or anything. It just starts saving. It'll save on the desktop with a timestamp. But the cool thing is, this is so cool. That it's frozen. Oh, there we go. It's probably still saving. So here it's saved not only the image, which is has full transparency, so they can use it in the magazine, but also save this text file along with it, which shows the random seed for the colors, how many attractors, the XY position of each attractor, and how many pixels. So then I can go load that back in, like after they choose their 4, I can load that back in, I can move the attractors around if they say they want it more vertical oriented, but same basic thing. I can kind of tweak it a little bit, and each time I save an image, it's going to save the parameters automatically, so I can always redo and tweak images like that. And so that came out about, I think, June 2010, like a 4-page spread. It was pretty cool. Oops, no calendar. So finally, just to wrap up here, how would you create tools? There's a few different cool things here. Tools to make tools. Minimal comps, how many people have heard of these? Quite a few. So I'll just give you a quick demonstration of those. So minimal comps are a set of components I made because I didn't like using Flex for quick projects, and the AS3 Flash components weren't too easy to use in ActionScript projects alone if you weren't using Flash. So I made my own. So they become pretty popular. They're minimal because I designed them to be very easy to use, not a whole lot of options. They're good for like fast prototyping stuff. So first of all, like when you're doing an ActionScript project, generally the first thing you want to do is you want to set the stage align and stage scale mode so that it doesn't scale out of whack and stuff. So I was sick of writing stage scale mode equals stage scale mode no scale, stage align equals stage align top left all the time. So I just made that a init stage method, and that's all done. Now normally if you write a button, like say you want to put a button on stage and assign a click handler to it, so you would create a button, you would give it an X position, a Y position, add it to the stage, set its label, and add an event listener for the click handler. So that's like 6 lines of code potentially. So I just wanted to make it one, so you say new push button, you see the parent, the X, the Y, the label, and the handler. And that's it. You have a button, right? And we can run that. And yes, yes, yes. So we have our button on stage, and we click it, and we have the message. We traced out a message down there. So it's great for rapid prototyping. They're not really meant for enterprise applications or large-scale things, but it enables you to write. They're great for writing tools where you don't need a specific look and feel, and you just need to bang out something quick. Good for experiments and stuff like that. Adobe Air is an awesome tool for writing tools because it gives you cross-platform. It's very rapid development, very easy to do stuff. You don't need to see my calendar. Go away. JSFL. We saw one JSFL example, the AS Expander thing. This is a book I co-wrote with Todd Yard back in 2004 that describes all of JSFL and the other tools that were released with Flash MX 2004. It's still, as far as I know, the only book on the extensibility layer in Flash. It's still out there, and they've added a lot to it, but I think everything in the book is still valid. If you're using the Flash IDE, and you want to get more productive with it, it's a great book to still go for. That's all I have. These are the people who provided the tool pictures on Flickr. And I think I'm just about on time. So any quick questions?
Can you make your presentation available?
Yeah, I'll put it up on my site if it's not already there. It might be there, but I'll make sure it goes up. Anything else? Yeah.
Sometimes we could create algorithms with pixel bender. Is the same principle that we could use for your Explorer application?
Yeah. I mean, Pixel Bender, in a sense, you can create the little sliders and stuff. It's an Explorer all by itself. But I think other people have written tools that allow you to, experiment with different filters in ActionScript and stuff like that. Okay, so I think I'll clear out of here, get ready for the next person. Thank you very much.